Right, gents, I thought this week was an appropriate time for us to take a little bit of a look at some exam style questions. Okay, so I've given you a sheet with three different questions on. The actual exam has got 4 questions in it typically, and you'll be asked to answer 3 of them in the 2 hours that you've got. Yep. So if we think about that, 120 minutes, 3 hours, yeah, about 40 minutes a question. Take away, I don't know, 20 minutes for just reading through the whole paper. My exam advice has always been read through the whole paper before you decide to do any question. Which one's my best one? You don't have to do them in the order they're presented. Get some marks on the board by doing your favourite question first, and always allow some time for checking back. And I'm religious in an exam. I've not done one for a long time, but I do what I've just done. Immediately work out how much time I got for each question. The marks are apportioned evenly, so there's 30 marks for each question, so that should be even time. But if it isn't even time, then I work out how much time I got for that question, and I time it, and if that time runs out, I stop on that question, move on, because generally questions build and get harder towards the end. So get them early marks on the board. You might get an easier one later, and you can come back to the bits you didn't do. But I've always been religious like that. In an exam, give it the amount of time that you got the marks for. So divide this up evenly. So you're going to get 3 questions like this. Okay, you'll note that in the example questions there is a little bit at the bottom where I'm testing knowledge in different areas. There's only so much I can ask, so I'm not giving that away in example questions. But you are expected to have an understanding of what power factor correction is and what the advantages and disadvantages of it are, as by way of example. Yeah. So it's a 2-hour exam, and you'll be expected to answer 3 questions like this. Yeah. And in these questions around power and in and out of phase components of current, the phasor diagram is king, really. That's all I can say. Draw your phasor diagrams. Make sure you know where each part comes from, and really you can't go wrong. That's simple trigonometry beyond that. Okay, so how are you getting on with this first question then? Typical exam question 1. Struggling? Yeah? Sorry? Part A didn't seem too bad, but you got stuck, fell by the wayside. Yeah? So what do you want me to do then? Start to go through this question? Yeah? It's just right. Nameplate and AC electric motor indicator is designed to be connected to a 600 volt single phase line. The motor has a full load current rating of 12.8 amps and a power factor of 0.75. Using this data, carry out the following analysis. Sketch the power triangle representing the meter readings and determine the active and reactive power absorbed by the motor. Okay, so what have you done so far with that? What does this power triangle look like? Yep. Label the sides. How do I label the sides? S, VA, power in watts. What else can I add to that? cos of the angle (0.75). Yep. Yep, good one. So we can start this problem. So that's part of A, okay? And you get some marks for getting all of that information on there. Yeah. The rest of A, what did you say, Alan? Sorry? S. Yeah. Because you've been given the full load current, so if that's running, the assumption is it's running at that full load, we've got 600 times 12.8 volt VA. Yep. Yeah, you can go cos of the angle is equal to P over S, isn't it? Is that what you're saying? That's what I've done. I'm just a bit. So that rearranges to P is S cos of that, which is 7680 times 0.75, which is what you've done. Yeah, you just written it out differently. I don't care about that. Yeah. The answer to that is all with that so far. Yeah. Or maybe. Yeah. And the last bit. Yep. And we're at the stage now where you should just be able to easily rearrange that to find any one of the three. So that's root of 7680 squared minus 5760 squared comes out at 5080 bars. So for getting a power triangle right, power theory, any type of power is the voltage times the relevant current. In the case of S, that's the actual line current. If that's Q, that's the out of phase component of current, and if that's P, that's the in phase component of current. But that is this formula here is the basic power as voltage times current version of the power formula. Yeah, this is basic trigonometry rearranged, and this is Pythagoras theorem. So nothing mathematically difficult. What I'm really testing is, do you understand the electrical theory behind it of power, in phase component of power, Q, out of phase component of power, S is the resultant or apparent power. Yeah? That's what's really being tested. The maths is not particularly difficult. Okay? So, part B. Determine the in phase and out of phase components of current, IP and IQ. What does this? What does this really call for? Do you think? I'll put this on the same page. What did I say up front? Phasor diagram. Well done. So we've got to have another triangle. But this time, that's IP, IQ, and the resultant current that's travelling down the line. We know what that one is. It's 12 point, what was it, 12.8? It was 12.8, wasn't it, Alan? Yeah. And what else do we know about that triangle? Looking at the data you've been given in the question, looking at what we put on our other triangle, yeah, the angle, the phase angle, the power factor angle is the same. So if that's where you got stuck, can you now find IQ and IP? Going to pause. Okay. Go on then, Tom. Tell me what to do. Go on. That doesn't matter.
12.8 times 0.65.
Yeah, so you've gone down this route of
The I line.
which rearranges to, yeah, IP is I line cos of the angle. That is 12.8 times 0.75. You'd be wholly correct in that. Well done. And then I'm just laying it out a little bit more fully. And if you do it that way and you're gone wrong, I can see where you're gone wrong for one thing. Secondly, you can be given some credit for the bits that you did get right. Okay? Yeah? Whereas if you make a mistake, this is not like that complex. If you make a mistake and you haven't laid it out in full, then maybe not so much credit but can be given for a wrong answer. Okay? And then, have you found IQ?
I think so, I don't know. But yeah, I've just done the same thing for the other question. Sorry, so yeah, IQ equals square root of S squared minus B squared.
S squared?
The I line.
I line squared
Minus IP squared.
minus IP squared, yeah. So that's the root of 12.8 squared minus 9.6 squared, and you got 4.7 amps is what I got on my sheet, yeah? So there or thereabouts. Okay. Don't want to cause confusion, but there is a totally different way you could have tackled the problem. Okay. Over here, P is equal to IP times the voltage. yeah, which rearranges to IP is P over E. What was the power? Just remind me. 5760 over 600 equals, and if you do that maths, you should get the same answer. Yeah? I think it better comes, you're a lot more likely to remember how to do it from the doing a phasor diagram, but this is an equally good method and we'll get exactly the same marks. And equally, Q is IQ times that same voltage. So all different versions of the basic power formula involving voltage and current. Yeah, and that rearranges to IQ is equal to Q over E, and the figures for that were 5080 over 600, and the answer to that is exactly the same, 8.47 amps. So unless you're asked to do it in a specific way, either are equally as good. Yeah? Same marks will be given for doing it that way and doing it that way. Okay? What about part C? Anyone started that yet? Do you want to start on it? What would the question says? Determine a phase angle between a line current and a line voltage. I would recommend it. So this is part C. Phasor diagram. Where would we draw the line voltage? In our phasor diagram, if that starts from here, where would I draw a line representing, yeah, horizontal? If I draw this one, and I'll deliberately only moved it up a little bit so you can see it, right, that's effectively along the same line. Which current is that? That's the in-phase current, which is I. Where's the out-of-phase current? IQ, and the line current comes from I line. Yeah. And what do we know about this angle in here from the question? Because that's what it's asking for. What's the phase angle between the line voltage and the line current? Is it? Don't look like it to me, Alan.
Oh, sorry, the line current.
We know the cause of this angle, 0.75. So it's asking, what is that angle? Because there's the line voltage, this one here, and here's the line current. So it wants to know, what is this angle in here in degrees. So cos is equal to 0.75, therefore is equal to, yeah, but what is it equal to in mathematical terms? Cos to the minus 1 of 0.75, and that comes out as 41.4 degrees. Yep. And the current is leading the voltage. Yeah, because we talk about it going round anti-clockwise. Yeah. Happy with that? Yeah. Well, your voltage and the current through any resistance are always going to be in phase with each other. So that if you drew that line, and that current up there, they'd still stay together, because through a per resistor, and that's the only thing that can give you active power. Remember, the voltage and current components must be in phase with each other. And then any other current, this one up here, this I line, is out of phase, and that one's out of phase as well. Remember, this IQ here is created by the inductance of the motor coil. Yeah, IP is the current due to the resistance of that coil. Yeah, and that's this power, IP, or the current due to IP, is the only one doing real work for you, creating heat or creating motion. Alright, going back to the question, what's the next bit? Calculate the reactive power needed from a power factor correction capacitor in order to improve the power factor of the motor to 0.9. Assume that the active power remains constant. What I want you to do is see if you can draw a power triangle, which is effectively two power triangles, one showing the old situation and then showing the new. So one's going to show the old S and the new S, and label that up, so you're showing the difference between without the power factor correction and with the power factor correction. See if you can do that. Recording this, but never mind. So you've gone down a slightly different route there. That's giving you what the new Q is. The question's asking you how much Q are you going to get from this capacitor. Yeah. So where does that come from then?
Minus the old.
Yeah. So QC, ultimately QC is equal to Q old minus Q new. That is, what was the Q old? 5080 minus 2790 equals yep, and that's within reasonable accuracy. I'm using my other method 2296, but my roundings might have been different. Okay, so there's nothing wrong with that at all, and you either go one way or they go the other. There's nothing wrong with that, and you've effectively answered part of the next question anyway, because it says determine the new apparent power. All right, but I think that's worthwhile me just going through what exactly is going on here. In terms of the power triangle. QC is down there. Yeah. What you want to do is imagine that QC as pulling this S line down this way. So what we end up with is a Q new in there, which is equal to Q old minus QC, because they always work against each other. This is Q due to the inductance of the motor, Q old is. We're now adding some capacitive Q, which is a totally opposite 180 degrees out of phase with the inductive Q. It's pointing downwards. They work against each other. So it has the effect of pulling this S line down to here. There's S new. And there is cos of the angle new, which is now equal to 0.9. So that's where that is phasor diagram, or power triangle wise, is we've added some capacitance into the circuit, pulling this S line down a bit, and we got a resultant new overall Q that is the old Q minus what we've added from the capacitor. Yeah? And then you'll go through the rest of the calculation. So here we can find Q new from the triangle, which is what Matt did anyway. Yeah. Alright, because this angle, we got the cosine of this angle, we know this side and we want to know that side, so I can find the angle come out at 25.8 degrees. Yeah, and I'm going to put this work dancer up on the site for you, so I don't want to go in too much detail, because then we can work with the tangent using power and the Q new to find Q new. Alright, we get Q new P times the tangent of that. That is 5760 times tan 25.8 degrees, and the answer to that came out at 2784 var. And then from that, QC is Q old minus Q new, same as before, 5080 minus 2784 equals 2296 bar. So it gives you the same answer, but I wanted to put that up for completeness so you see what's going on with the power triangle. No, QC is what the question's asking for. Yeah. So that must be the difference between the old Q and the new Q. Then in my worked answer, S nu is found the same way as Matt found it, using Pythagoras theorem. 6 2 summon VA. Yep. Into 6400, yeah? We can all make mistakes, so I went and I writ Q nu squared down and then put in the figures for the QC. Anyway, 6400, and then how do we calculate the the new line current from this information here? That's part E. New line current how do you go and get that? S new. Yeah, that comes, you're right, for completeness. S new is equal to E times I line, which rearranges to the new I line is equal to S new over E. 6400 over whatever the voltage was, 600 equals 10 2/3, isn't it? Okay, so that is typical exam question number 1. Typical exam question number 2. Let's just take a look at it and see what we got to do. This is one of these multiple loads questions. 2 resistive heaters, 3 inductive loads, a motor where you're given the kilowatts and the VARs, and a motor where you're given the kilowatts and the power factor, and 2 capacitors where you're given the VARs. It's one of these spider diagram things where you can add up all the powers, add up all the Q's, add up all the S's. So you've been asked to, how are you going to tackle part A? Draw what, Alan? Yeah, but the first part of the question is asking you, because the second motor on there, you've been given the power in watts, but you haven't been given the Q that's being drawn from the supply. So you've got to find that before you can put it on the spider diagram. So what you're going to do to get Q out of the information given here, 6.7 kilowatts and a power factor of 0.65. Going to draw a power triangle. That'll give you that data. You can then draw the diagram, and there's 6 marks for that. How are we going to determine the total power? Once we've drawn our spider diagram, total powers, all the powers added together. Total Q, add them all together. What we got to be careful with there though, we got 3 inductive loads that have got VARs. We've got 2 motors that have got VARs involved with them. And we've got 2 capacitors that have got VARs. What have we got to be careful of? Yeah. The motors and the inductive loads are opposite polarity in terms of power to the capacitors. So the motor and the inductors are said to draw reactive power from the system, and the capacitors give it back. So if you say the ones that are drawing are positive, then the ones that are given back must be negative. Don't matter which way round you treat those, as long as they are opposite to each other. You get the same answer. Okay, depends whether you're talking about what's being drawn from the system or what's being given to a system. And you'll find once you've answered B and you've got the total Q for part C, then how are we going to find the total S? When we got P and Q, how do we find S? We use Pythagoras theorem. Yep, so another 4 marks. Determine the power factor and the current drawn from the supply line. Power factor, power triangle of the whole system, yeah? So you, out of your complete P, Q and S, draw a power triangle for the whole system and determine the power factor. And then from the S, you can use the power formula to find the line current, okay? And then you've got another part of the question involving power factor correction there, okay? Similar to the one you've already done, so improving that overall power factor to 0.9. So have a go at that question.